In the early Showa period, high-speed internal combustion trains with an operating speed of 160 km per hour appeared in Europe and America, inspiring various attempts in Japan as well. Initially, most were small models intended for local lines, but they gradually became larger. By Showa 10, 1935, a full-fledged vehicle with a 19-meter body equipped with a 150 horsepower gasoline engine had been developed. The engine installed was the GMH-17, which later became the basis for the DMH-17, capable of producing a rated 150 horsepower and a maximum of 200 horsepower. The power transmission was a mechanical 4-speed gearbox, requiring the driver to operate a clutch pedal in addition to the master controller and brake. The advantages of the mechanical system were its simplicity and high transmission efficiency, and even with the 4-speed mechanism, the operational weight was only 33 tons. Compared to passenger trains hauled by steam locomotives, it was overwhelmingly nimble. At that time, the demand for transportation in urban suburbs was increasing, and there were high expectations for high-speed frequent services. Initially, 4 units were produced, and since there was no standard for railcar painting yet, 2 different types of paint schemes were tested. In the same year, a public run was conducted to showcase its high speed. The 2-car train, composed of different colors, was operated in a manner that chased after the then-called Super Express, Tsubame. Its speed was astonishing for the time, catching up with Tsubame along the way. Furthermore, it recorded a top speed of 108 km per hour, demonstrating the high speed of the gasoline railcar. Looking at the acceleration curve, the Kiha 42,000 overwhelmed the EF-53, hauled Tsubame at the start with the power of its transmission. In the mid-speed range, it fell behind due to the superior characteristics of the electric motor. However, in the high-speed range, the Kiha 42,000, which entered 4th gear, demonstrated its engine characteristics and continued to accelerate, leaving the rapidly declining performance of the EF-53 behind. On the other hand, in lines with high transportation demand, there were limits to handling with a single car. Vehicles that required manual clutch operation and gear shifting could not be controlled collectively when coupled together. Each car needed a driver, and operations such as notching, shifting, and braking had to be performed with signals from whistles or buzzers. However, even with this method, the limit was around 3 cars, and even at that time, commuter rushes were already occurring in urban suburbs, making it impossible to cope with just 3-car formations. In Germany, there were examples of mechanical total control using electromagnetic clutches, but in Japan, the only example was the adoption of the Kotal gearbox by Mantetsu. In Japan, where the development of automobiles lagged significantly behind Europe and America, the technology related to transmissions was also considerably delayed. Even though there was the technology to build the Zero Fighter and the Yamato battleship, the development of technology for machines running on the ground was significantly behind. Amid strong demands for longer train formations, expectations for electric power transmission, which could easily achieve total control, were growing. Additionally, from the perspectives of safety and fuel efficiency, there were high expectations for diesel engines over gasoline engines. Thus, a new railcar equipped with a diesel generator was planned. While mechanical railcars with diesel engines were still in the experimental production stage, plans for even higher output engines were made. The Ministry of Railways decided on the specifications, and 3 companies, Niigata Iron Works, Mitsubishi Heavy Industries, and Aikai Iron Works, independently designed and manufactured engines to meet these specifications, with 2 engines actually installed and 1 kept as a spare. The common specifications for the engines were a displacement of 30,540 cubic centimeters, 240 horsepower, and 1,300 RPM, designed to be mounted horizontally under the floor. The engine weight varied by manufacturer, ranging from 2.62 tons to 2.92 tons, and the generator was common at 1.85 tons. When the main electric motor was added, the weight of the main power unit alone exceeded 6 tons, making it quite disadvantageous in terms of weight. While overseas high-speed internal combustion trains adopted a semi-concentrated floor-mounted design, it was rare at that time to have a complete underfloor mounting even with around 240 horsepower, and the design was conscious of securing passenger space. However, the unfamiliar horizontal engine later became a source of frequent failures due to poor lubrication, causing problems on site. Except during idling, the engine speed was controlled to be almost constant at around 1,300 RPM by a governor. Therefore, the output was adjusted by controlling the generator, and the fuel injection amount was automatically controlled according to the load on the generator. Since it ran at a constant speed, fuel efficiency was good under high load, but it deteriorated under partial load. Although the engines were made to common specifications in terms of size and piping, there were differences in details such as the combustion method, resulting in differences in fuel efficiency, with Eikai's engine being the most fuel efficient. The formation consisted of 3 cars, with powered cars at both ends and a trailer car in between, and since it was based on a fixed formation, close coupling connectors were used for the intermediate couplers. The seat pitch was expanded from the conventional 1,300 mm to 1,450 mm, and despite being all third-class cars, the design was spacious. However, the seat backs were low, causing passengers' heads to touch those behind them, making it unsuitable for long-distance operations. The motive cars were 20 meters long, and the intermediate cars were 17 meters long. The leading motive car featured a streamlined design, which was popular at the time, to emphasize its high speed. Furthermore, the car body exterior had no rivets or protruding reinforcement plates, which were common at the time, resulting in a so-called no-seal, no-header construction. The innovative design reflected the high expectations for rapid railcars. Due to the heavy electric system, careful consideration was needed for the interior equipment layout, with the toilet and steam generator for heating installed in the lightweight intermediate car. Despite having two 240 horsepower engines, the performance of the 2M1T formation with the electric system was not impressive, contrary to its nimble appearance. The main electric motor switched to 60% weak field control above 80 km per hour to ensure high-speed performance, with a design speed of 120 km per hour. However, judging by the performance curve, reaching 100 km per hour was challenging. Since there are no records of high-speed tests like those for the Kiha 42000, the actual performance is unknown, but similar to the high-speed tests of the 151 series Kodama, it likely did not accelerate to the design speed without using downhill sections. It might have managed against steam locomotive-hauled trains, but when compared to other 3-car formations, it was on par with C12-hauled trains. It would lose against C58-hauled trains. Naturally, it could not compete with lightweight mechanical gasoline railcars. However, there were high expectations for comfortable railcars without smoke, and they were introduced into local train services, starting commercial operations. Once operations began, the previously mentioned engine troubles occurred frequently, and before the problems could be resolved, societal changes led to a shift to a wartime regime. Precious oil was prioritized for military supply, and it became unthinkable for railways, which could run on coal, to use oil. Alongside the development of the Kiha 43000, the design of a more powerful semi-concentrated high-speed train capable of running at 120 km per hour was progressing, but this too was naturally halted. The dream of gasoline railcars, and of course diesel railcars, vanished with the wave of war.